Welcome to this explainer. Today, we're looking at the ultimate clash of the titans, electricity and water. We all know they're mortal enemies, right? Yet somehow, we safely put them side by side in our homes literally every single day. So how do we pull this off without disaster striking? Well, we're going to unpack Section 6 of the AS/NZS 3000-2018 wiring rules. This entire section is dedicated to what engineers call damp situations. Think of this explainer as your guide to those invisible blueprints, keeping you safe when you're at your absolute most vulnerable.
Have you ever wondered about this? You're stepping out of the shower, soaking wet, and you have to do this awkward stretch just to hit the bathroom fan or the light switch. It kind of feels like terrible architectural design, doesn't it? But here's the kicker. That inconvenience, it's actually a highly calculated, legally binding safety measure. You are literally living inside a technical code book. Let's look at the exact rules dictating where those switches can and absolutely cannot go.
Okay, here's our map for today. We're taking a spatial journey, starting with the danger of damp situations, before moving into decoding the safety zones. From there, we'll walk room by room through bathrooms, showers, and sinks, head outside for pools, spas, and fountains, and finally wrap up with extreme environments in saunas and hosing down areas.
All right, Section 1. The danger of damp situations. Before we even touch safety zones, we need to nail down exactly what constitutes a hazard according to the standard.
So, the wiring rules officially define a damp situation as one where moisture is permanently or even intermittently present, to an extent that it impairs electrical safety. The crucial takeaway here is that water fundamentally changes the electrical environment. Why? Because the presence of water drastically reduces human body resistance. I mean, when you're wet or even just hanging out in a high humidity room, your skin's natural electrical resistance just plummets. This means the likelihood of your body making a fatal connection with the earth skyrockets, dramatically elevating the risk of electric shock.
Moving right along to Section 2, decoding the safety zones. To combat this massive risk, the electrical code doesn't just treat a bathroom or a pool as one giant danger box. Instead, it uses a brilliant system of classified, concentric safety zones. Let's see how they work. Think of these zones as invisible safety nets that get stricter and stricter the closer you get to the water. Step 1 is identifying Zone 0. That's always the absolute interior of the water container, like the inside of a bathtub or the floor of a shower. Step 2 requires an inspector to physically measure outward from that water source to establish the limits of the next zones, usually zones 1, 2, and sometimes 3, depending on the splash risk. And finally, Step 3 is applying strict equipment restrictions based on exactly which zone you're standing in. You can't just eyeball this. It's a game of precise geometry.
And this right here brilliantly shows how the safety hardware actually scales with the risk. Notice how the ingress protection, or IP ratings, shift depending on the zone you're in? In Zone 0, where full immersion happens, equipment has to be rated at least IPX7, meaning it can literally survive being submerged in water. But as you step out into Zone 1, which mostly faces direct splashing, the requirement lightens up a bit to IPX4 or IPX5 if it's a communal shower. Out in Zone 2, where splashing is pretty limited, IPX4 is the standard. Basically, the equipment's armor gets lighter as the threat of water diminishes.
All right, Section 3. Bathrooms, showers, and sinks. Now that we've got the theory down, let's see how this builds into our real-world spaces, starting indoors with the damp situation most of us navigate daily, the bathroom.
1.2 meters. Guys, this is a magic number in the wiring rules. If you've got a shower with a fixed plumbing connection on the wall, Zone 1 extends out as a strict 1.2 meter radius right from that plumbing connection. Imagine a giant invisible cylinder radiating outward from your shower head for 1.2 meters. Inside that cylinder, the rules are incredibly strict. Now, a physical barrier, like a shower screen that's at least 1.8 meters high, can limit this zone, but without one, that 1.2 meter radius is absolute law.
Inside that 1.2 meter Zone 1, and definitely inside the Zone 0 basin, the standard enforces some serious prohibitions. You are absolutely forbidden from installing standard socket outlets, regular light switches, and no way, absolutely not, switchboards. And here's a really fascinating detail from the source. The standard explicitly bans protective measures like placing out of reach or using basic obstacles. You can't just slap a standard PowerPoint really high up on the shower wall and call it safe. The moisture environment is simply too hazardous for shortcuts.
So what happens when you step just outside that 1.2 meter bubble into Zone 2?
Well, the rules loosen slightly, but they are still rigid. If you want a socket outlet in Zone 2, it can only be one of two things: an automatic shaver supply unit, or it has to be protected by a 30 milliamp RCD, a residual current device. And it must be physically enclosed in a cupboard that stays closed during normal operation. That is exactly why your bathroom vanity cabinets so often hide the power outlets inside them.
Moving outside for Section 4, pools, spas, and fountains. When we go from a shower to a swimming pool, we're suddenly dealing with full-body immersion and massive volumes of water. Naturally, this requires the most extreme safety engineering.
Let's compare the indoor and outdoor safety bubbles for a second. Indoors, the safety bubble is relatively tight. Zone 2 for a shower only extends 0.6 meters past Zone 1. But for an in-ground swimming pool, Zone 1 extends a massive 2.0 meters out from the internal rim of the pool. The standard completely recognizes that the splash zone, the wet bare feet, and all those outdoor environmental factors create a seriously escalated hazard that requires a much larger protective footprint.
I want to read this direct quote from the standard for you because it dramatically underscores the specific terror of electricity in a pool. Failure of insulation may result in a hazardous voltage appearing across or through the water. Think about that. In a pool, you don't even have to touch a broken wire to get hurt. If a fault creates a voltage gradient in the water, just being immersed in it is enough to cause severe harm at very low voltages. It's a sobering thought.
To prevent that terrifying scenario, engineers use an absolutely crucial solution called equal potential bonding. Honestly, this is arguably the most vital concept for pool safety. Equal potential bonding means connecting every conductive part near the pool. We're talking the steel reinforcing mesh inside the concrete shell, the metal ladders, the conductive pool fences within arm's reach. All of it goes back to the installation's earthing system. The standard mandates that the resistance between these bonded parts cannot exceed 0.5 ohms. This ensures that even if a fault occurs, everything around you is at the exact same electrical potential. Think of it like tying a bunch of boats together so they rise and fall on the exact same wave. If everything is at the same voltage level, it's virtually impossible for a lethal current to flow through your body. Finally, Section 5, saunas and hosing down areas. Let's finish our tour by exploring some niche areas that introduce completely different extreme environmental challenges, namely intense heat and high-pressure water.
Saunas are fascinating because they combine severe heat with moisture. According to the standard, Zone 1 is a 0.5 meter boundary directly around the sauna heater. Absolutely nothing is allowed in there except the heater equipment itself. But get this, even in Zones 2 and 3, which cover the rest of the room, you're entirely forbidden from having socket outlets or standard switches. The environment is just too punishing. Any electrical equipment that is actually allowed inside the sauna must have a minimum rating of IPX4B or IP24 just to handle the constant splashes and sweat.
And then we have sanitization and hosing down areas. Think commercial kitchens, dairies, or car wash bays. Here, the safety rules shift based on sheer mechanical force. If the area uses low or medium pressure hosing, the electrical equipment has to be upgraded to an IPX5 rating. But if they're blasting those walls with high pressure hoses, the equipment must achieve a rigorous IPX6 rating. The standard literally adapts directly to the physical velocity of the water being thrown around.
So, as we wrap up this explainer, I really want to leave you with this thought. Every single time you flip a bathroom switch with wet hands or jump into a backyard pool, you are being protected by a century of meticulous engineering and incredibly strict regulations. These invisible blueprints, these zones and bonding requirements, they're just working silently in the background of your life. So next time you notice that awkwardly placed light switch just out of reach from the shower, maybe don't curse the architect. Instead, take a quick moment to appreciate the incredible, invisible safety net that's keeping you alive every single day.